No, you cannot connect the air purifier to the line side of the disconnect. According to the National Electrical Code, all equipment and conductors must be protected from overcurrents. This means that a fuse or circuit breaker must be installed in series with the equipment to protect it from excessive current flow. In this scenario, the 30-amp disconnect is intended to protect the number 10 THHN conductors from overcurrents. If the air purifier is connected to the line side of the disconnect, it would not be protected from overcurrents because the disconnect would be downstream of the fuse or circuit breaker. To safely supply power to the air purifier, a separate disconnect and fuse or circuit breaker specifically for the air purifier is needed. The disconnect must be rated for 2.0 amps and the fuse or circuit breaker must be rated for 3.0 amps, which is 150% of the air purifier's full load current. The correct way to connect the air purifier involves these steps. Firstly, install a separate 2.0 amp disconnect for the air purifier. Secondly, install a 3.0 amp fuse or circuit breaker in series with the disconnect. Thirdly, connect the line side of the fuse or circuit breaker to the 480 volt line. And fourthly, connect the load side of the fuse or circuit breaker to the air purifier. Understanding overcurrent protection is crucial for electrical safety. Overcurrent protection devices, such as fuses and circuit breakers, are designed to interrupt the flow of current in a circuit when it exceeds a safe level. This prevents overheating, damaged equipment, and potential electrical fires. The National Electrical Code provides detailed requirements for overcurrent protection, including the selection and installation of appropriate devices for various types of circuits and equipment. The NEC specifies that conductors must be protected against overcurrent in accordance with their ampacity. Ampacity refers to the current carrying capacity of a conductor, which is determined by its size, material, and insulation type, as well as the ambient temperature and other factors. The overcurrent protection device should be sized to protect the conductor from damage due to excessive current flow, while also allowing for normal operating conditions. In this case, the number 10 THHN conductors feeding the 30-amp disconnect must be protected by an overcurrent device rated at 30 amps or less. Connecting the air purifier to the line side of the disconnect would bypass this protection, potentially exposing the conductors and equipment to overcurrent conditions. Tapping power from the line side of a disconnect without proper overcurrent protection is a violation of the NEC and creates a safety hazard. The NEC requires that all electrical equipment be installed in a neat and workmanlike manner. This includes ensuring that all connections are properly made, conductors are adequately supported, and equipment is protected from physical damage. Installing a separate disconnect and overcurrent protection device for the air purifier ensures that the installation meets these requirements. The 2.0 amp disconnect provides a means of safely disconnecting power to the air purifier for maintenance or repair purposes. The 3.0 amp fuse or circuit breaker protects the air purifier and its associated wiring from overcurrents. When selecting a disconnect and overcurrent protection device, it is important to consider the voltage and current ratings of the equipment being protected. The disconnect and overcurrent protection device must be rated for at least the maximum voltage and current that the equipment is expected to handle. In this case, the air purifier operates at 480 volts and draws 2.0 amps. Therefore, the disconnect must be rated for at least 480 volts and 2.0 amps, and the fuse or circuit breaker must be rated for at least 3.0 amps. It is also important to consider the interrupting rating of the overcurrent protection device. The interrupting rating is the maximum fault current that the device can safely interrupt. The interrupting rating must be high enough to handle the available fault current at the point of installation. In general, it is recommended to select an overcurrent protection device with an interrupting rating that is equal to or greater than the available fault current. When installing a disconnect and overcurrent protection device, it is important to follow the manufacturer's instructions and all applicable codes and standards. This includes ensuring that the equipment is properly grounded, conductors are properly terminated, and the enclosure is properly sealed. Grounding is an important safety measure that helps to protect against electrical shock. Branding provides a low impedance path for fault current to flow back to the source, which helps to trip the overcurrent protection device and to energize the circuit. All electrical equipment should be properly grounded in accordance with the NEC. Proper conductor termination is essential for ensuring a reliable and safe electrical connection. Conductors should be terminated using approved connectors and methods, and all connections should be tightened to the manufacturer's specified torque. Loose or improperly terminated connections can cause overheating, voltage drop, and even electrical fires. Enclosures are used to protect electrical equipment from the environment and to prevent accidental contact with energized parts. Enclosures should be properly sealed to prevent the entry of moisture, dust, and other contaminants. The NEC provides detailed requirements for enclosures, including the type of enclosure required for various applications. In addition to the specific requirements for overcurrent protection, the NEC also contains general requirements for electrical safety. These requirements cover a wide range of topics, including wiring methods, grounding, bonding, and equipment installation. Compliance with the NEC is essential for ensuring the safety of electrical installations. The NEC is a comprehensive document that is updated every 3 years. It is important to stay up to date on the latest requirements and to consult with a qualified electrical professional if you have any questions or concerns. The ODGE, or authority having jurisdiction, enforces the NEC and other electrical codes. The AHA may be a local building inspector, a state electrical inspector, or another qualified individual. It is important to obtain the necessary permits and inspections before starting any electrical work. Failure to comply with the NEC and other applicable codes can result in fines, penalties, and even legal action. In summary, connecting the air purifier to the line side of the disconnect is not permitted by the National Electrical Code due to the lack of overcurrent protection for the air purifier and its associated wiring. The correct method involves installing a separate disconnect and overcurrent protection device specifically for the air purifier, ensuring that it is properly protected from overcurrents and that the installation complies with all applicable codes and standards. This approach ensures the safety and reliability of the electrical system. The purpose of the disconnect is to provide a means of isolating the air purifier from the power source for maintenance or in case of an emergency. The disconnect should be readily accessible and clearly labeled. The overcurrent protection device, in this case a 3.0 amp fusor circuit breaker, is sized to protect the air purifier's wiring from damage due to excessive current. The size of the overcurrent protection device is based on the ampacity of the conductors and the characteristics of the air purifier. The conductors feeding the air purifier must be sized to carry the load current of the air purifier, plus any applicable directing factors. Directing factors are applied to account for factors such as ambient temperature and the number of conductors in a raceway. It's worth noting that the initial setup involves a 100 amp 3-phase 480 volt line. This line is likely serving other loads in addition to the 30 amp disconnect. The installation of the 30 amp disconnect with number 10 THHN conductors is permitted, provided that the conductors are protected by a 30 amp overcurrent device. The fact that the 30 amp disconnect is tapped off of a 100 amp line does not change the requirement for overcurrent protection. Each branch circuit must have its own overcurrent protection device. The length of the conductors between the tap and the overcurrent protection device is also a factor to consider. The NEC specifies the maximum length of unprotected conductors based on their ampacity and the size of the overcurrent protection device. In this case, the conductors run about 3 feet below the tap junction. This length is likely within the allowable limits, but it is important to verify this according to the NEC requirements. The air purifier itself should be listed and labeled by a recognized testing laboratory such as Underwriters Laboratories Incorporated, or all. Listing and labeling indicate that the equipment has been tested and found to be safe for its intended use. The air purifier should also be installed according to the manufacturer's instructions. The manufacturer's instructions provide important information about the proper installation and operation of the equipment. Ignoring the manufacturer's instructions can void the warranty and create a safety hazard. When working with electrical equipment, it is important to follow safe work practices. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves, and energizing the circuit before working on it. Always verify that the circuit is energized using a voltage tester before touching any conductors. Working on energized circuits can be extremely dangerous and can result in serious injury or death. If you are not qualified to perform electrical work, it is best to hire a qualified electrical contractor. A qualified electrical contractor has the knowledge, skills, and experience to perform electrical work safely and in accordance with all applicable codes and standards. In addition to the specific requirements discussed above, there are other general requirements in NEC that may apply to this installation. These requirements cover topics such as grounding, bonding, wiring methods, and equipment installation. It is important to be familiar with all of the applicable requirements before starting any electrical work. The NEC is a complex document, and it can be difficult to understand all of the requirements. If you have any questions or concerns, it is best to consult with a qualified electrical professional. A qualified electrical professional can help you to understand the NEC requirements and to ensure that your electrical installation is safe and in compliance with all applicable codes and standards. Furthermore, the selection of the appropriate type of disconnect switch is crucial. 480-volt 3-pole switch is suitable for this application, as it is designed to handle the voltage and current requirements of the three-phase circuit. The switch should be rated for the horsepower of the motor and the air purifier, if applicable. The switch should also be of a type that is suitable for the environment in which it is installed. For example, if the air purifier is installed in a damp or dusty location, the switch should be rated for that environment. The installation of the disconnect switch should be done in accordance with the manufacturer's instructions and all applicable codes and standards. The switch should be securely mounted and properly grounded. The conductors should be properly terminated and the connections should be tightened to the manufacturer's specified torque. The enclosure should be properly sealed to prevent the entry of moisture, dust, and other contaminants. The disconnect switch should be readily accessible and clearly labeled. The label should indicate the equipment that the switch controls. The switch should be operated regularly to ensure that it is functioning properly. The switch should be inspected periodically for any signs of damage or wear. If any problems are found, the switch should be repaired or replaced. In addition to the disconnect switch, the overcurrent protection device, in this case a 3.0 amp fuse or circuit breaker, should also be selected and installed in accordance with the manufacturer's instructions and all applicable codes and standards. The overcurrent protection device should be of a type that is suitable for the application. For example, a fuse may be used for a general-purpose circuit, while a circuit breaker may be used for a motor circuit. The overcurrent protection device should be sized to protect the conductors and equipment from overcurrent. The size of the overcurrent protection device is based on the ampacity of the conductors and the characteristics of the equipment. The overcurrent protection device should be installed in a readily accessible location. The overcurrent protection device should be clearly labeled. The label should indicate the size of the overcurrent protection device and the equipment that it protects. The overcurrent protection device should be tested periodically to ensure that it is functioning properly. If the overcurrent protection device trips, it should be investigated to determine the cause of the trip. The cause of the trip should be corrected before the overcurrent protection device is reset. In conclusion, a safe and code-compliant installation of electrical equipment requires careful attention to detail and a thorough understanding of the National Electrical Code and other applicable codes and standards. By following the recommendations outlined above, one can ensure that the air purifier is properly protected from overcurrent and that the electrical installation is safe and reliable. Always consult with a qualified electrical professional if you have any questions or concerns. They can help you to understand the code requirements and to ensure that your electrical installation is safe and in compliance with all applicable codes and standards.